Hey, what's up everybody? It is Mr. Boylan, and who is ready for some amazing nuclear decay practice? I know I sure am. So let's get started. Alright, now balancing nuclear equations is a fairly simple process. Let's take a look at this first equation that we have to work with. Essentially, you want the mass numbers, or the numbers on top of the things on the left, to add together to give you the same number as the sum of the mass numbers, or the numbers on the top, on the right. As I take a look at this first example, I'm trying to determine what this missing particle is. I know that it must have 0 mass, because 0 plus 14 is 14, and that's what the total mass is on the other side of the equation. Now, what number plus 7 gives me 6? Answer, -1. What type of decay has 0 mass and essentially a charge of -1? That's right, a beta particle. Now, remember, a beta particle is essentially an electron, and so you'll see it represented either by using the symbol for beta or an E for an electron, but they're the same thing. I personally like to be fancy and draw in a beta symbol. So, what type of decay do we have here? Beta decay. Boom! Let's take a look at example number 2. Again, same idea. We want the sum of the numbers on the top of one side of the equation to equal the sum on the numbers on the top of the other side of the equation. So, on the left-hand side of the equation, the only number on top that I have is 218. So the sum of all the numbers on the top on the right-hand side of the equation also have to equal 218. 4 of it is given to this particle here. That means 214 of it must be to this missing particle. Same thing applies to the numbers on the bottom. On the left-hand side, the total is 84. On the right-hand side, 2 of that 84 is here, which means that 82 must be the number on the bottom for this particle. Now, as I try to come up with the symbol, remember that the number on top is the mass and the number on the bottom is the atomic number. So I can just head to my periodic table, boom, scan my periodic table, find atomic number 82. It's lead. That's my symbol for my missing particle. Now, what type of radioactive decay is this? What type of particle was given off? This helium nucleus represents an alpha particle. So anytime you see one of these, you can recognize that that is going to be alpha decay. Boom. Keep in mind that some people like to be fancy, and sometimes you'll see the symbol for alpha instead of helium. Alright, last example for this video. Again, the numbers at the top have to sum together to equal the sum of the numbers on the top on the other side of the equation. On the left-hand side, the only number I have on the top is 226. So on the right-hand side, the numbers have to add together to 226. I've already got 222 of that 226 right here, which means that 4 must be the mass number of this missing particle. Same thing with the number on the bottom, except the numbers have to add together to 88. 86 of that 88 is right here, so 2 is going to be right here. You may already know what this is going to be, but if you don't, head to your periodic table. Boom. Atomic number 2 is going to be helium. Boom. Now, keep in mind that this also represents an alpha particle, so this is another example of alpha decay. Woo!